our talk is going to be, on WAFs. So let me introduce ourselves. So, Moin, Muzammil, I'm Najam Siddiqui. So we both work as architects and security architects for the cloud protection and licensing business unit in Thales. So we used to work for Gemalto, and Thales acquired Gemalto. Typically people, when we ask, they haven't heard about either Thales or Gemalto because we don't normally do a lot of consumer products with more business focus. So that's why. But we do work in the product that we're working now is SafeNet Trusted Access, which is identity and access management solution. So we and also previously we've always been involved in solutions that provide security, right? And being involved in that, so one of the things that we have to look at is how to protect our applications, right? And we've been using WAFs for almost quite a bit of time now. So we have an internal, deployment architecture for sort of a homegrown WAF solution that we use. But we have also looked at different solutions that are out there, from cloud providers and on-premise. So we're going to cover that. We're going to share our experiences and also the research that we did with you all today. So quickly on the agenda, so we're going to, go over a brief introduction of WAF and then cover the different options that are there. We'll be focusing on the, cloud provider and the self-managed options. We'll have a comparison table to where you can, have a good view of how they compare, some issues and limitations and questions. So just briefly, I hope everybody knows WAF, so I'm not going to read the Wikipedia definition over there, but WAF is commonly used, it's a security measure that is used to protect, your application against malwares, attacks, impersonation attacks, or, wide variety of attacks. So this is a very simplistic architecture. Typically there'll be a lot more components in a real, deployment. But this is just to give a view of where your WAF sits on your network, right? So you'll have on the left-hand side, your good guys, bad guys on the internet. Then you have your network firewall. Typically, your WAF will sit behind the network firewall. And then in the backend, you have all your backend servers. So the question is, why do we need WAF, right? First point is network firewalls, they are necessary, but they don't protect you against application level attacks, right? They can't inspect the HTTP traffic. They're limited to a job that they do. They do it good, but but they are not good enough for application level attacks. You have identity intrusion detection and intrusion prevention systems, but they also typically don't inspect traffic. So they don't cover, application attacks. Data leak protection, how do you protect data exfiltration? Typically, your WAF does that job. Hardening all backend applications, we might have hundreds of microservices, if not tens, if not hundreds. How do you protect all that, right? So it's hard and it's expensive, right? The WAF, in terms of the resource usage, if you have your WAF that can scale independently, it doesn't use the resources that your application use. So there is a good decoupling, over there. Some more points on why WAF. WAFs doesn't need to know your source code, right? Or it's agnostic of the technology. What it needs to know is typically HTTP, right? That's what it is protecting. So your application could be, .NET, Java, Node.js, whatnot. It doesn't need to know the source code. The other point is centralized hardening of TLS, right? Typically we see, that's the typically WAF will be your TLS termination endpoint, right? So you have one place where you can harden, right? All the backend application, you still need, to set up cert because you want encryption in transit end to end. But in terms of, let's say, if if the team finds out there is a vulnerability that is out there in, TLS, whatever 1.1, you want to block that, there's one place you block it, right? And then you can still go, you have more time to address it for your backend applications. Then it's your central point for implementing all your filtering for security, right? You don't need to, you can still have customized, customize based on special needs of the backend application, but it's your central point. Hot patching, right? As I mentioned earlier also, right? It's very easy. If you know that an application is supported, that one of your application is exposing something, let's say an admin portal, right? So you can get it very easy, go in your WAF and say, okay, this is blocked for external traffic, okay for internal traffic, right? So it's easy to do hot patching. And, it can detect attacks early, active attacks early. So now Moin is going to go over the, the details.
Yeah. So we talked about why we need, okay, maybe I need to, okay. Mute. Okay, now. Okay, that's good, I think. Okay, so we talked about why we need WAF. So let's talk about some of its basic features. Okay, looks like better. Okay, so one of the most important feature of WAF is that it acts as a reverse proxy. Basically, it takes all the requests from the clients and then passes those requests to the backend components. So there are many benefits of this approach. One of the most important one is your backend components are never exposed publicly. And it also makes your WAF as a technology agnostic. At the backend, you can have any technologies. Your WAF solution does not care about that. And also, it's very friendlier for your for your evolving products. You can add any new component behind your existing WAF, basically by just reconfiguring WAF with little effort, and you can add new components behind the scenes with little effort over there. WAF also implements the TLS, and as part of that, it also lets you choose what protocols and what versions do you support, like TLS, SSL. You can pick and choose those, and you can also enable Cypher suites, which you want to enable or disable over there. It also lets you intercept and filter out the traffic based on predefined rules. As part of those rules, you can decide whether you want to enable it, you want to disable those rules, disable the traffic, you want to block it, or you can just log that just for the auditing purposes later on. And another good thing about WAF is it supports detection mode as well as prevention mode. Prevention mode, basically, it would block anything which is violating the rules. But detection mode basically means it won't block anything. It would just log those things in the logs so that you can refer to that later on. And while we're on this topic is, whenever you're putting a new solution, WAF solution in production, it is recommended you should put that in detection mode for a short period of time so that you can review WAF logs and then basically adjust your rules based on those logs before you put that into prevention mode. The benefit of that approach is that you don't see the number of unexpected blockages in production would be reduced. So the false positives, you can reduce that right away. Another thing good about WAF is you can basically protect your resources with WAF. You can use the blacklisting or whitelisting approach to restrict access to the sensitive resources. And you can also use WAF to stringently monitor your traffic as well as the rate limiting as well. So we talked about why we need WAF and what are the basic features. Let's talk about the different WAF providers. So there are three major classifications from our point of view. One is the traditional firewall application providers, which were mostly the network ones. They also support now some of the WAF capabilities like F5. But then there are now the cloud service providers ones, like AWS, GCP and Azure, they have their own WAF solutions. And we also have some self-managed options as well. So for our talk today, we'll be mainly focusing on the last two. So let's start with the cloud provider one first, and then we'll move to the self-managed one as well. Check if it's still working. Is it still working? Check.
Okay, so first we're going to look at, so we were thinking how to best do it. We thought, let's just show a demo. So we'll cover the AWS WAF first, and just quickly go over the page. You see that there's AWS Shield over there, which basically protects against distributed denial of service attacks. It's not the WAF. And then you have your WAF. You can see all the features that it supports. Didn't get my glasses, so it's too small. So yeah, so over here, some of it I'll quickly cover. IP sets, yeah, you can group them together and refer them in a separate rule. Similarly, regular expression and so on. AWS Marketplace, that's a good thing about AWS is you can use. There are companies who have been doing this for a long time. They have really hardened rules, good rules, so you can use them. Obviously, you have to pay for it, subscribe to it. How you get started? First thing that you create is you have to create a web ACL, right? So your web ACL is something that you bind it with your entry point, whether it's a CloudFront distribution or load balancers or API gateways. So for today's demo, we'll just use a CloudFront distribution. You name it. And then you have to bind it to a specific resource that you want to protect. Here, you're not going to cover that part to a specific resource, but just wanted to show that what resources you can. And then you have your default options, whether to allow or block. Now, next thing is within an ACL, you have your rules that you need to define, right? So there's no limitation in AWS. It inspects only 8K of a request body, so that's right up there. Then you have your managed rules. In managed rules, you have free rule groups and paid bot control. This is something which is fairly new in AWS, which you can protect against bot. And then you have your free rules, admin protection, IP reputation is like Amazon has its own IP list of blacklisted IPs. Anonymous IP list, that's basically VPNs and proxies, known proxy, and some of the other rules. From the marketplace, you can, F5 is the famous one, so you can subscribe to any of these rules. But in the rules which are already there in AWS and all the marketplace, there's a lot of overlap. So you'll choose one, right? Not all. Once you have added all the rules, so what AWS does is each rule have conditions, right? It counts the number of conditions that are there, and there's a limit of 1,500 conditions that you can have in your rule. You can, call AWS to increase that for your account. You can also add, a custom rule. In this demo, we just add a simple rule based on the headers. We say that, okay, if a specific header matches a specific value, we'll just allow it, right? Or you can have a lot of, in custom rules, if you have, something specific to your application, then you can have custom rule to be able to protect it. So in this case, yeah, we're just adding, if the header is LASCON and it matches the value of demo, and then we allow the access. So there you go. So it's very easy to follow, right? You have your web ACLs, and you have your rules and conditions, right? With every a rule, you have to define whether you allow, block, or count. Count is basically just counting whether the rule got hit or not. If you want to put it in like just a learning mode, you want to see if it's being hit or not, you want to use that. The other thing that you want to say is the rules, the priority of the rules is the order that they are defined in. So you can move your rules up and down. It's different from the other providers where they specifically have the priority, numbers, but here it's just the order. I mean, you can go both ways. Here it's easier to see, have it sorted, first one. So the other point is these rules are disruptive in the sense if you hit a rule which says allow, that's it, you're allowed. It's not going to inspect the rest of the traffic, right? So, and if you hit a rule, so typically if you have your all blocking ones first and then you have your allows. If you hit a rule that says deny, that's it, it's denied, right? So it's pretty much the case with other WAFs also. So once you've created your, you have you have them. You can have multiples in the list. But you need to keep the bill in mind, right? It's based on how many you define and how much you're using, bind it to your entry points. Okay, so that's good. Okay, quickly, what we covered over here, again, Web ACL have rules, have conditions. Some of the features, I'm not going to cover everything. So new is bot control, and then the other thing is you can group, right? You can have predefined rules that you can group together. It's just a way of easily managing it. Rules from marketplace, it's pretty powerful. And then you have the WAF security automation. Doing WAF is not easy, right? How you deploy it. So AWS has a way where you can have automation for your deployment, right, with WAF. So that is something which is actually good. So next.
So similar to the AWS, we also recorded a demo video for Azure WAF. So I'm quickly going to go over that. So essentially what you would do is you would add a WAF resource from Azure portal. And once you add that, then you would define for which backend resource of Azure you want to apply that policy. So you can apply that WAF policy for your front door, your application gateway, or for the Azure CDN. So that was Azure front door, not for our houses. So once you do that, in my case, I'm going to do it for application gateway. Once I do that, next step is to pick the resource groups as well as the name over there for that. Next, I can choose between whether I want to enable the WAF policy right away or later on, and I can also choose between prevention versus detection mode. Next step would be to pick the manage rule sets. Here I can choose between different OAuth versions. And also, I can pick the bot detection rule set as well. So that one is also interesting because in this one, Azure maintains a list of malicious IPs, and then based on that, you can block a request to your application. And the list of IPs is not static. It's keep on being fed by the Microsoft Threat Security Analysis tool, and based on that, you can use it. Once you have done that, you can explicitly enable, disable individual rules if you want to. You can disable certain rules, and then you can use them. As the next step, you can exclude certain parts of your request from the WAF, the execution. Like you can say if this particular cookies or request headers or part of the request bodies, you can explicitly exclude them saying, okay, for those I don't want to apply the WAF rules at all. So if you want, you can do that. And you can also adjust your max body size as well as the file size limit. You can adjust it over here. Once that is done, on the next screen, you would be able to add custom rules. There are different options available in the custom rules. Like you can see if a request is coming outside this IP range, then block that request. You can do that. You can also add custom rules based on the different parts of your request. Like you can say if the parameter is part of this request body, your cookie, your header, your request URIs, based on those things, you can, depending on if it's an integer value versus string value, they provide different operators over here where you can pick and choose what kind of value you want to look for. And then based on that, you can allow or reject the traffic over there based on that. Another option is for geolocation. You can add a rule saying any request outside US, completely block that. One important thing to highlight is the priority, as Najam was saying earlier. In this case, the priority is the execution order of this rule. So the lower the priority, that means the earlier that rule will be executed. So that is something important to keep in mind, that when you are adding custom rules, refer to this priority field and add that accordingly. So in this case, as I said, I'm adding the rule here to say if the request is outside US, block that. Once I've done the custom rules, next step is basically link these WAF policy to your backend component, which could be the whole application gateway. You can apply this policy for the whole application gateway or to one of its HTTP listener, or you can also apply that to a particular route. So in my case, I added the full that to for the whole application gateway, and next step is to basically just create that. Once you do it, then the Azure would go ahead and set up the policy and apply the WAF based on your settings, and then you can use that. It takes a couple of minutes, so I didn't show you that part, just cut it short. So now, in terms of just to summarize what the demo covered, essentially is essentially the first 3 points. So not going to repeat that, but last part, which I didn't cover in the demo video, was monitoring aspects of it. So in the monitoring, the good thing about Azure WAF is it's very well integrated with the Azure monitoring system, and you can track the alerts and monitor the trends based on that. And that basically monitoring aspect is very good for Azure WAF. And also it integrates with the Azure Security Center, which essentially provides you the overall security assessment of your Azure resources. So it's very well integrated with that. So definitely helps over there.
Next, we're going to look at Cloud Armor. So Cloud Armor is the GCP WAF, that named it Cloud Armor. Google wanted to keep it different, right? So here you have, in GCP, you have your policies that define your rules, right? So the portal it's a pain to add policies from the portal. So for this demo, what I did was created a script, makes it easier to automate. So that is good, with GCP, you can use the API, you can use their gcloud command to easily automate, right? So here what I'm doing is just creating a policy, and then we'll go over the rules in that policy. So just to show over here that you can, create the policy from the portal as well. So you have your policy types, what you want to do with this rule, allow or deny, and then a lot of buttons to click. So basic mode, advanced mode. So advanced mode is something where you go and add your custom rules or predefined rules. The documentation is okay, but then still you need to know. So AWS, if you compare with AWS, their flow was very, very easy to. Someone who doesn't know the details still could do it. But here you have to know what you're doing, right? Otherwise it's not easy. So we just created a demo policy for this demo. We can quickly go over that. So first thing that we see over here, again, as Moin pointed out, here too on the right-hand side, you see the priority column, right? So the priority is the lowest number will hit first. The rules are disruptive. So if the first one gets hit, nothing else. So if there's someone who's trying to access /admin, it's going to be blocked because there's a rule which says to block /admin. If you want to allow access from your IP and not go through all the evaluation, you could do that with a custom rule to, for the IP, you're saying that if it comes from this IP, allow everything. Then the rest is basically adding the core rule sets, right? So there's a pre-configured rule set that are available in GCP. You can add them. So that's blocking against local file inclusion or remote code execution attack, blocking scanners, blocking protocol attacks. You can use the gcloud command. Unfortunately, from their portal, it's hard to see what all pre-configured rules are supported. So you need to use the gcloud command to get all the list of the different, pre-configured rules. So pre-configured rules, mostly they are core rule sets, or there are some more now they are adding, so there's constant work that is happening over there. And finally, your default action, you define, what you want to do, whether to allow or deny. As with everything else, you have to add a target where this policy will be applied to, right? The target could be your load balancers, the GKE ingress, right, or any other ingress. So that's basically your entry point that you want to protect. So quickly, we covered the policy, so I'm not going to go over there. A couple of things that we need, so GCP or Google does provide is managed protection, where they will manage the WAF for you. There's 2 layers of that. The other is adaptive protection, which is something new. We haven't tried it or used it. I think it became GA very, very recently. From what we have read is it's using machine learning to learn your traffic, and based on that, it can take actions. There may be some configuration. We haven't really tried it, so we don't know the details of how good it is, but I mean, the idea is to learn the pattern that is there, and from that, then you have the option to either take actions, block it, allow it, or whatever, or just log it.
Okay. So we looked at all the cloud service provider options, some of those. So next we want to talk about some of the self-managed options. Using mod security with Apache is one of the most common scenarios that you'll come across. So what we want to do is, I want to give you a quick overview of the steps you would need to perform to set up mod security with Apache. In my slides, the instructions are based on Debian, but again, the purpose is not to give you the exact instructions. They are very similar on the other versions as well. Mainly to give you the high-level overview, what steps you need to take, just to make you aware of that. So what you need to do is, first thing, you need to install the mod security on your for Apache on your machine, and then you need to configure mod security. And for that, you can use the recommended configurations provided already as is. But just there's one thing you need to be aware of. By default, those configurations are in detection-only mode. So you need to change the sec rule engine to on to make it basically in prevention mode. So you need to do that change. Once that is done, next step you need to do is you need to download the core rule set from Spider Labs. You can get those. And once you download them, you need to set up the CRS setup file. And again, you can use the provided file as a reference, and you can tweak that based on your need. There are quite a few rules over there. Quite a few are commented out, and they explain for each rule, okay, this rule does this. So based on your needs, you can adjust that. And then once that is done, you would update your Apache security configuration to add reference for your CRS setup file, as well as the rules which you just downloaded from the Spider Labs. So quick recap so far, what we have done is we have just installed the mod security, and we have set up the Apache to use the mod security configurations, as well as the CRS rule set, basically. And next, if you want, you can add some custom rules based on your requirements. Once that is done, you can test your configuration by sending a curl request to your Apache server with a script injected in that. And if everything was configured properly, the server should return you 403 back as an error code. And in that case, and you can obviously look at the more details in the Apache logs. If that happens, that means the mod security is configured properly and it's working fine for you. So again, the purpose was just to give you a very high-level overview of the steps what you need to perform to set up that. And Apache being the most common scenario, as I said. The next one is Nginx. Again, also a very common scenario we see in the industry being used. But again, I don't want to repeat all those slides again for Nginx. Don't want to bore you further. So we'll just leave you with some of the links. So as I said, the steps are very similar to Apache. The only difference is for Nginx, you have 2 options of installing mod security. One is if you are using Nginx Plus, then there is an Nginx mod security WAF dynamic module. You can use that, which is as an additional cost. You can use that. Or you can build the mod security on your own using the Nginx connector. And then you can configure that with your Nginx server over there. And again, I added the links for both of those. So take a look at that if you need to. And once you have the mod security configured with Nginx, if you want to enable more security for your particular site, the only thing you need to do is basically add those 2 lines to enable more security for your particular site over there. So now the next thing I want to cover is that's a pretty uncommon scenario, but still sometimes you need that. So for all the scenarios we covered, whether it was cloud service provider options or the self-managed ones, they were the scenarios where we were using WAF as a reverse proxy. So the WAF was in between your clients and the application. But in this case, you may have a requirement where where you need to support the mutual TLS authentication. In that case, your TLS needs to terminate at your application, and you cannot have the WAF in between over there. So how do you handle those scenarios? We talked about all the benefits of WAF. Now, in this case, you cannot use WAF, so how do you address that? You still want to take benefit of all the mod security and all the WAF features. So, as I said, it's not a very common scenario, but it's a scenario, it happened with us, so we know. So in that case, the good thing about it is you can embed mod security within your application. And recently, especially with the mod security 3.x, they did a very excellent job of re-architecting the mod security, of separating out the cores from the connectors. The connectors are essentially the communication pipeline between the app server and mod security. So you can use that to embed with any application server which supports the connectors for that. So right now on the Spider Lab Git repository, they already have the connectors available for Nginx, Apache, and Python. And there are a few others also available, like the one we used recently was for Node.js. And that connector we used for one of the POC, we used for PKI authentication. And it worked very well. We were able to integrate with mod security very easily with our application. We were able to integrate with the OS rules, as well as we were able to define custom rules over there. So, and at the end, it was not that difficult to do. So the important thing is, what I want to highlight here is, even though there's an uncommon scenario, but keep that at back of your mind. If you ever run into those kind of scenarios where you need to support a mutual TLS authentication, then you can still embed WAF and get benefit out of that using this approach. So we talked about the cloud service provider solutions as well as the self-managed ones, but there are some major differences, and we'll talk about some of the comparisons specifically in the next slides. But here I want to highlight some of the challenges which you would run into with self-managed WAFs. So depending on your team capacity and your deployment structure, how much work you need to do, you may need to factor that in as well. So for self-managed, so the cloud service providers, the good thing about them, they give you a very fancy UI or command line tools. You set up the WAF policy over there, and after that, they go behind the scenes, set up everything for you, and you can use that right away. But for self-management, obviously, the onus is on us. We need to go and deploy that on our own infrastructure, whether it's VMs or Kubernetes or OpenShift in case it's a Dockerized WAF. Again, there are some options available for that, so you can use it. Then also the security hardening of WAF, the earlier example that Najam was giving about the hot patching, again, in this case, we are responsible to do that. If there is an OpenSSL vulnerability, you need to go through all your WAF deployments and patch that individually over there. Similarly, another good thing I like about the cloud service providers, they give you the production-ready, highly available solution out of the box in a matter of clicks. You don't need to do much. But in this case, it's again on us. We need to have a highly available solution for your customers. What typically it means, you need to deploy WAF across multiple VMs and then have some load balancer in front of that so that you can route the traffic accordingly. That leads to the next challenge over there, which is the self-managed WAFs. There is hardly a way to do central management of that. If you need to patch anything for the WAF or change rules, upgrade stuff, you need to individually go to each of the VM and apply those changes. Obviously, you can automate that, right? There are tools available for it, but there's nothing available out of the box. You need to do something to take care of that. Either keep on doing manually or do some automation somehow. Again, the monitoring, there is nothing again available out of the box. There are logs available, but you need to hook it up with your existing monitoring system and implement some listeners or alerts based on top of that. Last thing, but not the least, is mod security is, to me, it's not simple, it's complex. And if you want to do self-managed WAF, you definitely want to have team expertise for that, because there would be cases where you would need to you need to customize the rules. Again, just enabling, disabling rules, that's simple. Okay, you don't need to worry about that. But there would be cases where you want to do hot patching scenarios, where you want to block stuff with the custom rules. That's where it becomes tricky. So you want to have definitely team expertise with the mod security to be able to adjust the rules if need be. Okay.
Now we look at the comparison. We didn't look at everything, but these are some of the highlights in terms of the comparisons. We are not going to go through the full table, but just what is also highlighted in this table, right? So one thing that a core rule set is pretty much supported in all the options. But what I wanted to mention over here is the core rule sets upgrades, right? So WAS is continuously working on the core rule sets to improve them. How do you, quickly add it or implement it in your solution? With your self-managed option, you have full control over it. Which version you want to use, as soon as there's a new version available, you have control over it. With cloud providers, you are dependent on the cloud providers, right? And we saw, I think Azure gives you an option of which version you want to use. AWS and GCP, they don't even list the options, right? Whatever is available, you have to use that. The other is the request body parsing. So we saw that with both AWS and GCP, it's limited to the first 8K of the request body. With your own, mod security, it's configurable, so you can do, 8K or 8 megs or whatever you want. Azure supports full request body parsing, so that is good. Response body parsing, we have a clear winner over here is mod security. With the cloud providers, they don't support request body parsing, right? So, and request body parsing is, response body parsing is critical for protection against data exfiltration or data leaks. HTTP 3 support, only GCP had that, so you want to list over there. IP filtering also, so GCP supports a dynamic third-party list, right? Instead of the others, it's a static list that you want to use, right? Another important point over here is how to handle false positive, right? So there are going to be false positive, right? False positive, basically, it's a valid use case and your WAF is blocking it, right? Now you have to do something about it, otherwise your customers cannot use your solution. So, what's the point? So now the thing is how to handle that. So with mod security, you have more granular way to add exceptions to those, right? So you can see what is the condition that is blocking, right? So some header value, the URI, or there's a specific condition that is there, so you can poke a hole only for that condition. Whereas for the other providers, you have to remove the rule. You don't have an option. If this is that something a valid use case is getting blocked, you have to remove the. So you're poking a bigger hole. So some issues and limitations that we have experienced for the time that we have been using WAF. Handling false positive. It's a continuous effort. It's not that you handle false positive once. Your applications are being continuously developed, evolved, right? And there's continuous delivery that is happening. Every week you're deploying in production. So how do you ensure that, you don't have false positive? And how do you poke holes? You don't want to poke so many holes that you don't even know how much WAF is protecting you or not, right? It's just like a perception, then you're being protected. So that is the a very challenging thing that we see, right? And it's a continuous effort. And because it's a continuous effort, the cost is high, right? So you have to, every time you make a release, there's this thing you have to test, right? And as I mentioned before, is in terms of how big of a hole you're poking, right? So managing the false positive without sacrificing security. The other challenge that we see is reproducing customer issues, right? Customer comes with an issue that, okay, I do this, it gets blocked, I get this message, and you look at that message, oh, it's coming from WAF. So now, when I try it, I can't reproduce it. Customers have their own cookies, they have their own plugins, there's customer-specific data. So how do you reproduce it? I mean, good thing is, yeah, you can go and find it in the log that it's being blocked and then figure out what's happening. But, it's a challenge. The other thing is getting 100% test coverage. So with WAF, obviously, as your application is evolving, WAF is evolving, there's continuous upgrades that are happening. So when continuous upgrades are happening, and we have actually got bitten by this, we upgrade WAF, and then suddenly we see the rules that were working before are not working, or there are use cases that were working before are not working now, right? So how do you ensure that when you upgrade WAF, that you are good, right? You need automated testing for that. But the trick is, or the challenging point over there is how do you get 100% coverage? We need to keep in mind it's not just like your application testing, functionality testing. That is very, very specific to there's no, let's say, variables, not many variables over there that are dependent, which you don't control. But with WAF, there is customers may be using different browsers, as I mentioned, cookies and plugins and whatnot. So how do you have a good test coverage that will protect you, or with confidence you can say, okay, we are upgrading WAF and we are not going to have any issues. So that's all we got. Questions?
So you're thinking about the test coverage. Actually, if you wanted to use synthetic monitoring from the performance testing, then you could actually take a look at what your end users might be experiencing for that reproducible customer. That's also as your QA folks are generating their functionality testing, all they need to do is a synthetic one. And the other thing about synthetic is you can actually stress test to see when your WAF is going to fail open or fail close. So by adding in the performance synthetic monitoring, you could actually add in a lot of coverage. So I don't know if you guys have...
Yes, we do that. Okay. Yeah, we do that. What I meant over there was having 100% coverage, right? You will have your synthetic monitors, you're doing some testing yourself, you had your own automated test suite, but the challenge over there is having 100% coverage.
Yeah, and the issue that we come across is like sometimes the users are having some plugins installed on their browsers, and those plugins are adding those extra headers, right? That has nothing to do with the actual request which is being sent to your application. But those extra instruments being added by the plugins, and the WAF ends up blocking those. Similarly, the customer has a data which is like accents or those kind of things. For America, it's working fine, but for European friends, okay, it starts causing issues over there, right? And our applications are actually deployed across all around. So for one of our zones, it's working perfectly fine, no issues. But as soon as you put it on European zone, it brings its own set of issues. When you go to Asia zone, it brings its own set of issues. So it becomes, and again, given the amount of traffic that is on our environments, it's difficult to figure out each individual user data being sent. So that's where the challenge was. And as Nitin was saying, again, we learned it the hard way this time, because we upgraded to a newer version rule set for OAuth. Everything was working fine, but as soon as we put in production, I was saying, okay, you normally want to put that in detection mode for a while. In this case, we don't have an option because we already have the WAF running in prevention mode. Now we cannot tell customers, okay, we are reducing the security level now. So as soon as we put it over there were escalations, things which was working end up getting blocked. So now we end up coming with our own framework to test stuff. At least things which were working before, we want to make sure they are passing. Irrespective of the rules, they are mainly based on the request which was working before should be working again. So that's the strategy we came up with now. But again, it's still a long way to go. And again, we are also thinking about maybe add this new WAF in detection mode behind the current WAF, so that you can monitor the traffic over there for a while before you replace this with the old one. So again, there are a few strategies we are thinking, but again, still debating on it. But yes, it's a challenge right now.
So
So given the issues, limitations, challenges that y'all outlined, why didn't you use one of the like established vendors?
What do you mean by established one? The cloud service provider ones?
Yeah, like one of the other, like the big WAF vendors. I mean, how come y'all did it yourselves?
Do you want to take that?
Okay, there's a history behind it. So as I mentioned, we've been using WAF for 10 years or maybe a little bit less. So one reason is it's a company mandate, right? So it's a corp security mandate that we have. I mean, the mandate was we have to use a WAF. And 8 years back, then we had an internal team that was basically developing a WAF. It's basically Apache with mod security, right? And that was an easier option to use. And then it's one thing with that is it's agnostic to what. I mean, whether you are in the cloud or data center, you could use it. At that point, there were no cloud options available. So we've invested in that quite a bit. It's working well for us, so we want to stick to that.
In addition to that is, it's not just the OS rule sets. The internal product that our company provides has its own set of rules, and they also keep on getting involved. And actually, we recently tested, we did a study like earlier this year, where we tested the rule sets, our own rule sets against AWS, and I think it was GCP also. So I think there were three, the default mod security, our own product, AWS, and I think GCP as well. And we tested the rule coverage against that. There was a major difference between what we are covering as opposed to what those are covering, right? And again, the other thing you notice, right, some of the things which Najam showed in the comparison table at the end, like response, it's not covering at all. Or the amount of request body it can pass.
Right.
So there are still a lot of limitations in the existing cloud service provider ones, which our company don't like. So they say, okay, no, we want more control, and we want to have our own rule sets to protect those common scenarios as well. Yes.
But I think there's going to be a tipping point.
Yes.
At some point, we are going to realize that it's expensive for us.
Yeah. As part of that study, they actually gave now a kind of a condition map or something, decision tree, saying, okay, if you're doing this, then this cloud service provider is okay. If not, then go this route. So they gave certain conditions saying, okay, if yes, no, yes, no, yes, no, and then you finalize, okay, this is the option you can go with. So they are also saying, okay, you can start using the cloud one, but for certain scenarios, not in all cases.
Okay.
Yes.
Thank you.
How resilient have you found rule sets to be to things like just alternate encodings, Unicode as opposed to ASCII characters, all these evasion techniques to get past pattern matching?
So the rule sets, I mean, cover that, but there's no 100% coverage for that. Right?
Yeah, and that's where our company rules, they keep, what I was mentioning, we keep on adding custom rules. There is a team in our company which, that's their job, right? And they keep on adding new rules to cover those kind of stuff to cater for that. And that's where when I was saying there is a major difference between our own internal product versus the other ones, these are the things they were covering over there as well. So but again, as Nadine said, they still won't be 100% coverage, but they have pretty narrowed down stuff also over there to cater those cases.
As with everything else, it's a cat and mouse game in security. You're catching up.
I did have another question. I saw the announcement from TrustWave that they stopped selling mod security this summer on August 1st and basically end of life in a few years, right? Have you seen the open source community really pick up the support of mod security? Just since you work with it day to day, I'd love whatever insight you have into what's going on there.
So as Moin mentioned, we have a dedicated team for it. So they're looking at good experts, and as I mentioned, there'll be a tipping point. So probably that would be the the push.
Okay, any other questions for us? If not, thanks again. Thank you. Thanks for.